guys, Assalamu alaikum. Field of force and electric field lines. Today's our lecture. And here in this lecture we are going to explain something about field of force and electric field of lines with a really very easy method. Here I'm going to show you some snaps related to this article, and here I am Sajid Ali going to give you some concepts about the field of force and electric field of lines. Let's begin with electric field of lines. So electric field of lines, first of all, we should have to get an idea about the electric field of lines, actually from where they their knowledge come from. So Michael Faraday introduced the concept of electric field of lines, and according to the theory of Faraday, it is the intrinsic property of nature that an electric field exists in the space around an electric charge. When we talk about the electric field of lines, field of force is a vector field. Here we can have an idea from this figure that the electric field of lines on a positive charge having outward direction. All of these electric field of lines having outward direction, and when we talk about the negative charges, so all the electric field of lines having inward direction. And field of force is a non-contact force. Field of force is a non-contact force means there is nothing physically attracting or repelling to each other, but the forces are present in the between the charges. Here from this figure we can have an idea about the non-contact force. Non-contact force means this apple is falling down from the tree and there is no physical force which is attracting this apple towards the earth. And next, this electric field is considered to be a force field that exerts a force on other charges placed in that field. Here we have a positive charge, and these dots are showing that the electric field of this positive charge, and the strength of the dots is much greater closer to the charge as compared to the far away of this charge. And if we place a positive point charge, with this within the field of this positive charge, then we will have a repulsion force to this point charge. For measuring some kind of experiments or performing experiments, we use this method. The density of dots is proportional to the strength of the field at the various points. We can define electric field intensity E at any point in the field. So electric field intensity E can be written as electric field intensity E is equal to F by Q naught. Here F is the force exerted by the positive charge on the point charge, and here Q naught is a point charge. So the Coulomb force that this charge will experience due to Q, that is F is equal to 1 over 4 pi epsilon naught Q naught by R square. And here this R is a unit vector. Where R is a unit vector, here we are talking about this R. Here this R is a unit vector directed from the point charge Q naught to the test point where Q naught has been placed. For example, the point where the electric field intensity is to be evaluated. Here I'm gonna show you this equation as an equation number 1. So we have a formula from the previous page. E is equal to F over Q naught. So by putting the value of this F into the equation, E is equal to F over Q naught, we will have here, after putting the value of F in this equation, we will have E is equal to 1 over 4 by epsilon naught q naught by r square r unit vector times 1 over q naught. So after cancelling q naught with q naught, we will have E is equal to 1 over 4 by epsilon naught q by r square into r unit vector. Here we have the units of the electric field intensity. E is equal to the units of E electric field intensity are Newton per coulomb. So let's begin with electric field lines. Electric field lines are imaginary lines. They are not real lines which can be seen with our naked eyes. These are just imaginary lines drawn in such a way that their direction at any point is the same as the direction of the field at that point. And when we have a positive charge, the direction of the electric field of lines is outward. In the case of negative charges, the direction of the electric field of lines is inward direction, and the field lines go away from positive charge and towards negative charges. What? The field of lines going away from the positive charges and coming towards the negative charges. So electric field of lines, here we have this diagram for showing something very special about this article. To introduce electric field of lines, we place positive charge each of magnitude q naught, each of charge having magnitude, these all of the positive point charges having magnitude q naught at different places but at equal distance from a positive charge, and all of these point charges having equal distance to this positive charge which is showing in this figure, and each test charge will experience a repulsive force as indicated with arrows in figure. Therefore the electric field created by the charge q, it means this charge plus q, is directed radially outward. So it is showing that the electric field created by this positive charge is direct radially outward, and this charge will repel to this point charge radially in this direction, and it will repel to this charge in this direction, and in same outward radially it will repel all of these point charges. So let's begin. Examples of electric field lines. Examples of electric field lines: when we have two charges, one is a positive charge and the other one is a negative charge. So we know the electric field of lines having direction from positive to negative, and when we talk about these electric field of lines which are not directly connecting with the negative charge, so these lines, if having a potential to complete the circle which they have, they will come towards the negative charge. And if these lines such for example this line which is moving straight from here, these electric field of lines will not complete the circle, either they will move straight, and for this purpose we can say that the electric field of lines at a positive charge are much greater than the electric field of lines at negative charge. And when we talk about the same positive or negative charges, when we talk about the same charges, positive or negative charges, they will repel each other, and their schematic diagram will be looks like this. Then we can say that the electric field of lines will never intersect each other at any point. So we can conclude this discussion as the notice that lines leave positive charge, these lines are leaving a positive charge and enters negative charge and entering in the negative charge. And the second thing also, electric field intensity E is the strongest where field lines are most dense. So the electric field of lines will be strongest where the field of lines are dense, are very close to each other. So properties of electric field of lines, what are So what are the electric field of lines? Properties of the electric field of lines. The first one, property of the electric field of lines. Electric field lines originate from positive charge and end on a negative charge. So the target to a field line at any point gives the direction of the electric field at that point. The lines are closer where the field is stronger, and the lines are further apart where the field is weaker. No two lines cross each other. This is because E has only one direction at any given point. If the lines cross, electric field intensity E could have more than one direction. Thank you very much for watching this video.